Welcome back to the next session of the chapter Laws of Motion. Friends, today we are going to discuss the topic called circular motion. Till now we studied the linear motion. So what is the main difference between the linear motion and the circular motion? Suppose if you consider a path on this palm, if you consider a path, if the body is moving continuously without changing its angle, then that type of motion or the motion possessed by the body is called as linear along the line. And in circular motion, or when the body is moving in the circular motion, at every instant of time, the angle of the body is changing with respect to its velocity. Or suppose if a body is moving in the uniform velocity in the circular motion, the angle is changing continuously, right? So question comes here, why the angle is changing continuously? The answer is very simple. When an external force acts on it, I repeat, when an external force acts on it, hence at that time, every instant of time, the angle keep on changing. As a result, instead of linear motion, the body shows or the body possesses the circular motion. Now, when the body is moving in the circular motion, three things should be in our mind. First thing is the mass of the body. Second thing is its velocity. And since it is a circular motion, one geometrical concept called as a radius we have to take the consideration. So now, if I define or one force which is changing the direction of the moving body, right? So at that time, an external force which is changing the angle of the moving body continuously, right? And the question is, the force, the external force which is acting on the body, in which direction it is acting? Answer is very simple. The external force which is acting on the body towards the center, right? An external force is acting towards the center when the body is moving along the radii, you can say, along the radii of the circular path, when the body is moving in a circular motion. Hence, such type of force which is acting towards the center, along the radii, which is called as centripetal force. The first force which comes in circular motion is called as centripetal force. Centripetal force. So what is the meaning of centripetal force? The dictionary meaning of centripetal force is center. Petal means loving. It's called as a center loving force. So that means what? This force is always acting towards the center of the circular path. So I can define this, centripetal force. It is acting along the, if I write the definition, it is acting along the radius, towards the center of circular path, towards the center of the circular path, and it's given by C is equal to mv square by r, or also called as Fc is equal to m into omega square into r. This already we studied in the previous chapter, where m is the mass of the object, v is the velocity of the object, and r is the radius of the circular path. Or m is mass of the object, omega is the angular velocity or angular frequency into radius of the object. This is one concept. Though it is not there in this topic, why I am discussing in the circular motion, there is an important reason. Now friends, as I said here, the centripetal force is acting along the radius. towards the center. Right, it's acting towards the center. Take a stone, take a string, then tie it to one end. Then start rotating like this. If you start rotating, this itself is acting as a center. The wrist itself is acting as a center. Then if you start rotating, keep on rotating, the stone is rotating round the clock. Right? Suppose if you leave the string, question comes. As we know that the centripetal force acting along the radius towards the center. But when stone is released from the knot, will it come towards center? No, it won't come towards the center. It will go away from the center. That means what? The centripetal force has some physical significance or physical source, right? Physical meaning, or I can say the better word, the physical origin. But if we take the another force, when the stone is released, it is moving away from the center. Then if you want to understand this concept, let's take another concept. If we apply the Newton's third law to this circular motion concept, what it says, centripetal force is the one force which is acting towards along the radius towards the center of the circular path when the body is moving along the circular motion. Fine. But if you apply the Newton's third law, what Newton's third law says, for every action there is an equal and opposite reaction. If there is equal and opposite reaction, there must be equal and opposite force, which is exactly opposite to the centripetal force. Then what that which is opposite to the centripetal force, and that force which itself is referred as centrifugal force. This is referred as what? Centrifugal force. So what is the meaning of centrifugal force? Then if I take the dictionary meaning of this, again it is centrifugal means heading. Center heading force. It is moving away from the center of the circular path. Now, let me take one simple example. Already I referred here. All the satellites which are revolving around the earth, the necessary centripetal force is exerted by the gravitational force. All the electrons are revolving around the nucleus. The necessary centripetal force is exerted by the electrostatic force of attraction. Right? These are all one concept when it comes to centripetal force. When it comes to centrifugal force, as I said, centrifugal force don't have any physical origin. Please keep it in mind. If there is a centripetal force, there must be a centrifugal force. Let me give a simple example. Right? Suppose if you are sitting in a car and you are taking the diversion in the curved path. So if you are taking a diversion in the curved path, or if you are sitting in the window side, if the vehicle is moving in this direction, your body moves in this direction. The body is towards the center. The car, the vehicle, the bus is applying the centripetal force. But to attain the equilibrium position, to retain the rest position, what will people do? You will bend towards the wall or towards the window. Why? That force, even though you don't have any physical origin, but it do exist. And that force itself is referred as centrifugal force. The force which is acting along the radii away from the center. It is acting away from the center. Such type of force is called as centrifugal force. Actually, as I said here, centrifugal force don't have any physical origin. Hence, this force is called as fictitious force. Fictitious force. Or also called as, one more is there, pseudo force. Pseudo force. One more name is there. It is also called as false force. As I said here, the centripetal force and centrifugal force are just like, they are mutual to each other. Since the centrifugal don't have any physical meaning, physical origin, but it has got its own magnitude, and the magnitude is given by, as that of the centripetal force, is given by Fc equal to mv square by r. Right. This is very much required in the study of the circular motion in this topic. So to give the foundation for this, I explained both the forces together. Right. So now, friends, by understanding the meaning of the centripetal force and the centrifugal force, let us understand, let us apply this concept, right, to study our day-to-day life problems. Right. So now that will be discussed now. Now let us study the applications of the circular motion. The first application is motion of a car on level road. Now friends, please keep in mind the motion of a car on circular level road or level circular road. Look at this. This is the nature of the road, and this road is flattened, not edge or one edge of the car is road is raised to a certain height, not like that, not like this or not like this. It is just flattened but circular. So when the car is moving on this leveled circular road, then how many forces are there on this car? That you have to study. The first force, because of its mass, it's acting downward. It is given by F is equal to mg or W equal to mg. That is one weight which is downward acting downward. At the same time, normal reaction which is exactly upward or perpendicular or vertical component called as capital N. And one more thing is friction. As I said here, since there is no acceleration and the body is or the car is moving with uniform acceleration, hence we can say that the necessary centripetal force is the necessary centripetal force is of the car is produced given force is given by Fc is equal to mv squared by r, where r is the radius of the circular path, where v is the uniform velocity, m is the mass of the car. And here I said here, when the car is on the leveled circular road, two forces are here, the normal reaction and the downward reaction, vertical downward, vertically upward. So this normal reaction is completely nullified by this mass. Hence the car is in a uniform motion because both are equal and opposite. I can say here N equal to mg. Normal reaction is equal to mg. That I can write here. And at the last I can write here. So there must be a centripetal force. The necessary centripetal force must be provided by the, let me write one sentence, necessary centripetal force must be provided by static frictional force. Static friction. So if I write the static friction, I can write already in the previous video we know that the static friction is given by Fs is equal to mu s into L. The static friction is given by Fs is equal to mu s into L. Right? Mu s into N. And to attain the uniform motion on the leveled circular road, the necessary centripetal force must be equal to static friction. So that means I can write here Fc is equal to Fs. This is Fs. Then already we know that what is this normal? This is a coefficient of static friction. This is static friction or static force. Then Fc is given by what? mv square by r is equal to mu s into L. After this, so now n equal to mg are there. We know n equal to mg. Substitute here. I get mv square divided by r is equal to mu s into m into g. M get cancelled. So finally, if I write, I get v square equal to mu s into r into g. Then if I take v, then v equal to square root of mu s into r into This is the velocity of the object when it is moving, in a circular leveled road. Then suppose if the velocity, look at this, if you look at this equation, so velocity is equal to, depending on the static coefficient of static friction, radius of the circular motion, and the gravity. That means here there is no mass. That means when the body is moving on circular leveled road, the velocity of the car is independent of, I repeat, it is independent of mass of the car. Suppose if I take this as a maximum velocity, Vmax, so I can write here Vmax is equal to square root of mu s into Rg. That means it is not at all depending on the mass of the car. Suppose if this car is moving more than this, if Vmax increases, so automatically what happens? The car gets skid or it slips, because it is not at all depending on the mass. So mass is not a matter. Whatever may be the mass of the car doesn't matter. If it exceeds the maximum velocity in the curved road or leveled circular road, suddenly the car gets skid. So this is one important application of this circular motion. Now the second application is the bank road. What is meant by bank road? We'll discuss in detail now. Let us study the second application called as motion of a car on bank road. Just now we derived one maximum velocity if the leveled curved road or circular road. Then we derived one equation, Vmax is equal to square root of mu s into Rg, where mu s is the coefficient of static friction and R is the radius of the circular path and G is the acceleration due to gravity. Friends, whatever the Vmax they are referring it is the safe, I said here, for safer traveling purpose, that Vmax should be, the velocity of the car should not exceed Vmax. Suppose if exceeds, there is no safe at all, because as I said, if it exceeds, automatically the car gets skid. Now, if the road is level and circular, there is a lot of friction. There will be a lot of static friction. So, to overcome from this static friction or to reduce the static friction, so one should contribute to decrease the static friction when we are moving in a circular motion. Then what we have to do? We have to bank the road. So what is meant by banking of the road, or a road should be banked? So what is the meaning of road is banked? That means what? If we consider two edges of a road flattened like this, one edge of the road should be raised to a certain height with outer edge with respect to the inner edge, then that is called as banking of road. So let me write the definition of bank road. So now the definition goes like this. That means outer edge of the road, outer edge of the road is slightly raised above the inner edge. See, I have shown one diagram here. The white line indicating here horizontal surface or horizontal plane. In that, this is considered as inner edge, this is considered as outer edge. Suppose if I draw a diagram here, it goes like this. Then, the inner edge is written as it is, but outer edge is little raised. Then there is an angle between the inner edge and the outer edge, and that angle is given by theta. Right? And that is called as angle of banking. That theta is itself is referred as angle of banking or banking angle. Now friends, now listen carefully. There is an important 5 marks derivation on this topic. The derivation question goes like this. Derive an expression for maximum safe speed. I repeat, derive an expression for maximum safe speed of a vehicle on a banked road in a circular motion. So that means we have to derive this derivation. So we have to start our derivation in the banking of the road. So now what we are doing in the banking of road? Outer edge of the road is slightly raised above the inner edge. Is called banking of road. Banking of road. Then look at this. Then again we discuss the same concept what we discussed in the previous application. If I take this, so this is the mass. If m is the mass of the car, is moving with the uniform velocity, then its weight is given by W equal to mg, which is acting vertically downward. But since road is banked, one edge is raised above the angle, then the normal exists like this. Then there is a normal existing in this path or in this direction. So this is the normal. This is the normal. At the same time, in this diagram itself, I can show here the frictional force. So this is the necessary centripetal force called as Fc. Necessary centripetal force. Then Fc is given by like this. This is Fs, static friction. So if I redraw this diagram on this side, it comes like this. Right? So this I am taking this line, same color only. This is the road, bank road. Right. So here is the horizontal. Here is the horizontal. There is angle. Then here I am considering one important point here. And with respect to that point only, let me draw all things. So this is the normal. This is the weight, W equal to mg, right. So now this is the necessary centripetal force. This is the what? Necessary centripetal force. Let me write it as Fc. Now friends, as I said here, the static friction is acting in this direction towards the center. Now the normal component should be resolved into its constituent components as vertical component and horizontal component. So if I resolve, so then there is an angle and this is called as n cos theta, then it becomes n sin theta. At the same time, the static friction also divided, that is component also can be resolved into one more thing, that is called as Fs cos theta. Fs sin theta, then it becomes Fs cos theta. So it becomes what? Fs cos theta. Now look at this. I am resolving this static friction into two components, as one vertical component, another one is a horizontal component. And the normal is also resolved into two components, as one is vertical component, another one is a what? The horizontal component. So whatever the angle we referred here called as road of banking angle, so same angle is also here. Now look at this. If you look at the diagram, the vertical component, that is n cos theta, Fs sin theta, and W equal to mg, they are going to generate the zero force on the body. That means what? There is no contribution of these two forces on the car. As a result, the net force due to the vertical component is zero. Let me write that one. The net force on car due to vertical component is 0. Due to vertical component is 0. Let me write that one in the form of equation, that is both are equal. So I can write here n cos theta is equal to these two are, that is f s sin theta plus mg and if I rewrite this equation, if m is equal to, then it becomes mg is equal to n cos theta minus fs sin theta. So equation number 1. This is all only the vertical component. Let's go for the horizontal component which are producing the necessary centripetal force. Right? Horizontal components are producing or producing necessary centripetal force. What is our intention? Our intention is to decrease the frictional force or static friction. So now, these two components are producing the necessary centripetal force. So that I can write here Fc is equal to n sin theta plus fs cos theta. Already we know that what is meant by centripetal force. Centripetal force is given by mv square by r is equal to n sin theta plus fs cos theta. So equation number 2. So this equation is a horizontal component. This equation is a vertical component. What I will do? I will divide equation 2 by 1. I am dividing this equation with this equation. So suppose if I divide, what happens? Let's write that one. So mv square by r into divided by 1. Now I divided the LHS part. Let's go for the RHS part. RHS part, this one, first one. This becomes n sin theta plus fs cos theta divided by n cos theta minus fs sin theta. M get cancelled. So we will write it v square by rg is equal to n. Then we substitute static friction. Fs is equal to μf n, because as I said here, to reduce the static friction, we have already in the previous discussion we know that static friction is nullified by the normal, that is given by Fs equal to μs into n. That only I am substituting here Fs equal to μs n, and this becomes n sin theta plus μs n cos theta divided by n cos theta minus μs into n into sin theta. I will write this part. Just borrow that equation step by step. Then if I write here, it becomes v square by rg is equal to, look at this, n is common, take it outside. Then if I take outside, along with that, we take cos theta to outside. So I will take the entire concept, that is n cos theta outside. If I take n cos theta outside, what is left over inside the bracket? Let's discuss. So if I write the numerator, n cos theta is taken outside. So insert bracket left with sin theta by cos theta plus first term sin theta by cos theta plus μs, only μs, because already n cos theta is taken outside. This μs is the numerator divided by. Let us take the same n cos theta outside in the denominator. If I do, then it becomes n cos theta inside bracket. So n cos theta entire term is taken outside. 1 minus mu s is retaining and n is already taken outside, so it becomes mu s into sin theta divided by cos theta. So n cos theta get cancelled. Take this rg this side. This becomes v square equal to rg into. Then divide, get sin theta by cos theta tan theta plus mu s divided by 1 minus mu s into sin theta by cos theta again tan theta. Then here only, if I take square root on both sides, it becomes v equal to rg into tan theta plus mu s divided by 1 minus mu s into tan theta 1 by 2. To this equation only, if mu s is equal to 0. Why mu s equal to 0? Because as I said here, motion of the car on a backboard means we want to decrease the static friction to a 0 level. So that means what? The static friction should be 0. The coefficient of static friction should be 0. If mu s equal to 0, I can write here v is equal to mu s 0, then it becomes rg tan theta. That is square root of. So now again I can write here v max is equal to v max is equal to square root of rg into tan theta. That means again, if the car moves with this angle, that is tan theta, that is into radius of the circular path and the acceleration due to gravity, then the car will be moving with the safer speed. So when the car is moving in the circular path, we are very much bothered about the circular path as well as the safer speed. So now, based on this banked road, so we can go with a safer speed, so with a uniform velocity. So that is v max is given by square root of rg into tan theta. If mu s equal to 0, then v obviously becomes v max. So now, if it is leveled circular road, so v max is equal to square root of mu s into rg. There is a static friction because it is depending on the there is no banked road, there is a static friction. But when the road is banked, then there is no static friction because it moves with a 0 friction. So that is only required. But friction is little bit required to move safely on the road. But practically it's not possible. But theoretically we can say that if the car moves with speed, so there is no friction between the road and the car. And the last topic is solving of problems. The solving of problems in mechanics. So when in the solving of problems in the mechanics, friends, first we have to read the problem very carefully and we have to draw the diagram, necessary diagram. So if it is required diagram, then draw the necessary ray diagram or picture, so with the given fundamentals by showing the direction of the forces. After that, note down the data, that is converting the data into sentences into data. What are the things are given, then what are the things are asked. So if diagram helps us to solve the problem, so then you have to go through the problem, given data. After that, whatever things are asked, most of the questions are asked from the banked road only. So now, or else Newton's second law. So then apply the formulas, then substitute the given data and try to arrive at the asked thing or the demanded thing. So with this, I am completing the chapter laws of motion. Thank you.